what we're looking at here a lot is to start the idea of just ordered pairs. And how do you draw them within space and which quadrant things are and things like that. We all know that general two-dimensional space is broken into 4 quadrants. 4 quadrants, you have your quadrant 1, quadrant 2, quadrant 3, kind of redundant here, and then quadrant 4. You also know that ordered pairs have different signs, SIGN, depending upon, or their x and y values have different signs, the SIGN, as they go around in the quadrants. Here, positive, positive, negative, positive, negative, negative, and positive, negative. That bit of information is going to become more important probably come Monday. My best guess, for how much we got through during second hour today, is that I thought we might be able to start a little bit of 13.3 Friday, but I highly doubt it, which is fine. Being able to get through and understanding how things get placed is one of the more important things. I'm going to start to introduce you guys to what's called a reference angle without theoretically calling it that yet, so you get the idea of how things move. So if it takes us 2.5 days to get through this one unit, fine. This is one of those sections that we have to really, really understand that it builds into everything else. Okay? We also know how many degrees it takes to get around in a circle, correct? 360. So here would be 0. This would be 90, 180, 270, and 360. So what happens here is that as you start talking about angles, you can have either positive or negative angles. Now, I know you look up and go, what? Negative angles just means it's going a different direction. Think about, you can't have negative distances, but you can walk backwards. It's that kind of a concept. If you walk to the right on the xy grid, you're going positive. You walk to the left, you're going negative. That's what the idea is. It's a concept. It's not a value. It's a direction. It's more of a vector and things like that. So what we do here is we start talking about angles and how they're placed. Angles are always placed with what we call a initial side at 0. Your initial side of an angle is always placed at 0. If you remember from geometry, like day 1 of geometry, you talked about like segments, points, lines, planes, things like that, angles. And you said that angles were made up of 2 rays. The 2 rays had a common endpoint. That common endpoint was called the vertex. Good. It's called the vertex. Okay. So what happens is, let's say I have an angle that is 110 degrees. How I would draw that is I place one ray, at 0, and I move it up. Well, 110 degrees is past 90, and it comes around like this at 110. And this side is called the terminal side. It's where it stops. It's where it terminates. It won't be back. It just gets worse.
I said it's going to bounce.
Yeah. So the terminal side is where an angle position ends. The terminal side of 110 degrees puts you into which quadrant? 2, because it's past 90, but it's not past 180. One thing I'd like you guys to start thinking about is once you get things placed into a quadrant, just off the top of your head, just start thinking, how far is it off of the x-axis? How far up is 110 from 180? It's up 70 degrees from that. There's a reason why I want you to start thinking about that as we go on. I'm setting the stage for important things. Yeah. No. Okay. All right. Let's try another one. If I say I want to place negative 300 degrees. If I want to say negative 300 degrees, well, that means I have to determine direction because of negative. Well, positive angles, I've shown you my angle symbol before, right? The angle with the little arc on it. Positive angles go, yeah, right. Counterclockwise. Negative angles go clockwise. So when I say it's a negative 300 degrees, the initial side still starts at 0, but it's just going the other direction. Okay, it's going to go clockwise 300 degrees versus counterclockwise 300. No. If you go, your initial side is still at 0. Oh, here, I don't know why I did here. If you start on your initial side at 0, you go 300 degrees. Well, here's 180, 270, so I'm up here somewhere. What quadrant does negative 300 work into? 1. Oh, because if you went positive 300, you come back around here, and you're in quadrant 4. Big difference. Yes, ma'am?
Are we going to have to find like points on a circle, like 2, 2 or something, to find out where the angle goes?
Eventually.
Are we? Okay. But like for now, I'm just going to kind of like eyeball it?
Yes.
Okay.
Yes. And it's not going to be anything like, it's going to be horribly bad. It's pretty easy, because you know where halfway is. You know where 45 to add in 45 if you have to. So it's smidging. But what you're getting at is eventually I'm going to give you guys an set of ordered pairs. And you're going to find all values of theta given set ordered pairs. And the ordered pairs will place you in a quadrant, which will allow you to then see where your ordered pairs move and why your sine, cosines, and tangents are positives and negatives. All relation to which quadrant things lie upon. It's a really crazy idea, but we'll do that probably Monday, as I'm thinking. How about you guys?
Negative 300 is the same as 60.
Yes.
How would you draw negative 3?
We just did.
Just that little.
Yep. By showing the loop around, that tells me that that's a negative 300 degrees. And like you were saying, that it is 60 degrees off the x-axis.
I just thought you were putting something like
No. No. Were you going to ask?
I was just going to ask, if we're doing a negative angle, would the space left be positive or negative? Like,
Always positive. Your distance is, yep. Yeah, when we're measuring these distances, what I'm trying to get you guys to do, or get the habit of looking for, I'm doing it a little bit different than I've done in the past. What students a lot of times happen is that, depending upon where their angle gets placed, they always have a hard time remembering if they're trying to move back to the x-axis or a y-axis. By asking you guys, starting day 1, how much is left to get to the x-axis? How far is this from the x-axis? How much to get back to the x-axis? How much to get back here? I'm trying to embed in your mind early to always find the distance back to the x-axis and never the y-axis. You never worry about the y-axis.
that wasn't supposed to be a pun. I was actually asking why.
Because, and I knew you were going with that, and I was going to say why. Well, because what happens is, like Hopper was just asking, isn't that the same as 60? Yes, because what you're measuring here is you're finding what's called a reference angle. And we'll get into more of that later on, because the reference angle of 60 degrees is the same reference angle in the first quadrant as it would be in the second quadrant, as it would be in the third quadrant, as it would be in the fourth quadrant. That distance never changes, which means eventually ordered pairs only change their signs, SIGN, as we go through. It's deep, but that's why.
That doesn't really answer why So that's why.
Because when we get to the ordered pairs, you'll see why. Okay? Now, what Hoppenworth was just asking, isn't this the same thing as a positive 60 degrees? Yes. Yes, it is. That's called a coterminal angle, which leads me to another definition.
How do you say that?
That.
Coterminal?
Coterminal.
Oh, Megan, you said coterm. That's because I was like saying it while you were reading. She's like coterminal.
Anyway, coterminal angles are angles that share the same terminal side. They're angles that share the same terminal side. Remember, the terminal side is where the angle stops. And a really, really easy example of this is to go back to the 60 degrees. If I place a 60-degree angle, we all agree that 60 degrees is the first quadrant. It's just up here at 60 degrees. Now, the next time that I get to that 60-degree angle, if I started at 0, I'd have to go around 360 degrees and then move back up 360 degrees. So what do I do to the 60 to get to the next coterminal? You add 360 to it. 360 and 60 is 420 degrees.
Wait, can we also just do negative 300 and 60 and equal terminal?
That's, you were going to look at positive and negative coterminal. You could have
Just add 360 to
pretty much. Unless, and we'll get to this, depending upon, well, all right, let me write this out. The rule is add and subtract 360 to get one positive and one negative coterminal angle. So like we did a second ago, if I subtracted 300 from 60, I'd go the other direction, and I'd be at negative 300. So 60 degrees, 420 degrees, negative 300 degrees, all three of those angles are all coterminal. I can add another 360, I can subtract another 360. I'm just looping around, and I'm still ending up at the same spot. Every time I go one full revolution, I'm going to be at the same place. Whether I'm going positive, going around counterclockwise, or I'm going around clockwise, negative, every time I move 360 degrees, I'll wind up at the same spot. Just like if you stand up and you spin around, aren't you still facing the wall, or the front board? You spin around 360, you're there again? Yeah. Well, yeah.
It depends on which way you're standing up.
True.
You stand up and then you
Now,
you're facing that way.
The rule about this is if your angle that you have starts within, you're going to hear me use this term a lot, within one revolution. What I mean by that within one revolution means is it between 0 and 360 degrees. If your original angle is between 0 and 360, all you have to do is add 360, subtract 360 to get a positive and a negative. If it's beyond that, you have to move the angle to become within 360 degrees. So that means you might have to add and subtract 360 twice. That's about it. I'll show you an example. Let's do another one of these. Let's say coterminal of 200 degrees. If I want to do coterminal positive, coterminal negative 200 degrees, first thing I do is place 200 degrees. Well, 0, 180, and I passed it 20 degrees. There's 200 degrees. You okay with that? So if this is off 20 degrees, I'm just going to put that here so I know how far off it is. Well, if I start back at 0, to get to 200 after I pass it again, I have to do that. Well, that's 360 plus 200, which is 560. To go the other direction, to go negative, I start at 0 and I go to negative 90 and I come back up. Well, I'm going to be 20 degrees off of the x-axis. If I went all the way up, I'd be at negative 180, which means I'm at negative 160. About what? Okay. Placing the angle. Okay. If you start back at 0, go all the way around. You're at 360. How many more degrees does it take you to get back to where you were for that 200 degree angle? What's 236 plus 360? 560. That's what we're doing. Since I'm within one revolution, I'm adding 360 and I'm subtracting 360. Now, if I'm past that, if I start with an angle that is, let's say, 500 degrees. If I started an angle that's 500 degrees, actually, let's do this. Let's make this negative 400. Let's make it different. We'll do a negative one. If I start with this at negative 400 degrees, that means directionally I'm going clockwise, and I'm back into quadrant 4. Are we okay with that? If I went negative 400 degrees, how many degrees did I go past negative 360? 40. I'm 40 degrees past it, so it's 40 degrees to get back up. Okay. So this angle here is negative 400 degrees. Since I'm past one revolution, one full time around, I need to first find the angle that's within one revolution and then the positive one. So what I have to do is, well, excuse me, I have to go around again. If I just go around to here, that's still negative. Oh, I'm sorry, I went the wrong direction. Sorry, I did the positive one. If I'm going negative, how far did I go? 40. So negative 40 degrees would be its negative coterminal. The positive is going this way, and it would be at 320 degrees. It's the idea of how far did I bounce off that x-axis to know how many degrees I'm going to wind up placing. Basically, in this case, since I'm beyond 360 degrees negative, all I have to do is add 360 to it. There's my first one, and I add 360 again. There's my second one. There's your positive, there's your negative. Yes, ma'am?
So the original coterminal will never be over negative 360 or positive
Yeah.
360?
You always, whether let's say you're at 900 degrees, you would spin it back to be within 360 degrees, and then you use that as its first coterminal, and then you go past it again, go negative. All right?
Wait, why do you go add 2 360s to it?
Because the first angle is beyond one time around. Whenever you're beyond one time around, you have to back it to be within one time around.
Okay, and then you just do it.
Exactly. Whether you're going positive, or if you're going negative, you do the same idea. You're just adding or subtracting 360 on multiples. Okay? That's all it is. That's like the weird thing of this, by being able to place stuff. Okay?
You have to
Yeah.
What if it was like a really big positive?
Then you just keep subtracting until you get within.
Just keep what would be the positive?
The first positive number between 0 and 360. So if you start at 900,
Yeah.
subtract out 720, you're at what, 180? Because you had to back it out twice. So there's your positive at 180. Subtract it again, you're at negative 180. Those are 2. You just keep going until you're within one revolution. So if you're at 9,416 degrees, keep subtracting 360 until you get there. No, maybe. I don't know. I try to keep it so numbers because you don't need a calculator. This. Ah, radians. Probably. Well, you have enough space. We are. Radian. Radian measure deals with. Radian measure is going to deal with, instead of 360 degrees, it's going to deal with it in terms of a circumference. So what I want you to think of is if you have a grid, if you start at 0, you come back around to 360. Everybody okay with that? The circumference. What is the circumference of a circle? Yes, sir.
It's like the perimeter.
It's like the perimeter. What is the formula for the circumference of every circle? 2 pi r. Very good. Does the r value matter for circumference? No. Because no matter what your r value is, you're always going to multiply it by 2 pi to get the circumference. So what happens here in terms of radians, radians are measured in terms of pi. So if it's 0 to start, 1 full revolution would then be 2 pi. 1 full time around something is 2 pi, which means half of 360 is 180. So what's half of 2 pi? Pi. What's half of 180? 90. What's half of a pi? So here's what I want you to see. We start adding these things in terms of fractions. I'm going to leave the pi out of it for a second here. If I start at 0, 1 half, 2 halves, 3 halves, and that's 4 halves. This is 3 pi over 2. Okay? I'm counting fractions. What's half of 90? 45. Half of 90 is 45. It doesn't have to be perfect. Half of 90 is 45, which means half of a half is what? Very good. Half of a half is a fourth. Count fractions. 1/4, 2/4, 3/4 at 135 because I'm adding 45 degrees. 4/4 is a whole. 5/4 would be 45 degrees past 180. 6/4 simplifies to be 3 halves, so you're back at 270. So 1/4, 2/4, 3/4, 4/4, 5/4, 6/4. This one's going to be 7/4 at 315. Because if you go up 7/4, you add a fourth to it, you're at 8/4. And 8 over 4 is 2. So you work through that. Now, you guys have already had special right triangles that dealt with 45s and 90s. Hey, look at all that. Oh. Exactly. What's the other special right triangle that we have not discussed yet? 30-60. Now, what's the relationship of 30 degrees to 90 degrees?
1/3.
It's a third of it, isn't it? What is You don't need to memorize the chart. You don't. And I will show you why probably tomorrow or Friday. And quite honestly, Sadie, and I've done this a lot. I mean, obviously I've done this more than you have, but if you can do the first 3 angles, everything mirrors itself by counting fractions. If you can count by a fourth, a sixth, and just simplify it, everything else is quick. It's just the idea of knowing how it starts. And this is why I'm showing it to you. So 90 degrees, 30 degrees is a third of it. What is 1/3 of 1/2?
1/6.
1/6. So a third of pi over 2 is? What's wrong?
What's gonna happen?
You will see.
I saw somebody in the
That means every 30 degrees, I can continue to make this. 30 plus 30 is 60, plus 30 is 90, plus 30 is 120, plus 30 is 150, 180, 210, 240, 270, 300, 330, and 360. Each of those values tick up 30 degrees, which means 30 degrees to 60 degrees, 30 degrees, pardon me, from 0 to 30 is 1/6, which means I add another 1/6 to get to 60. What's 1/6 plus 1/6? Which is
1/3.
third. And you get pi over 3. Because now all of these go by a 6. 1/6, 2/6, 3/6, 4/6, which is 2/3.
I don't even know what. I
Don't.
should have drawn this longer.
Probably.
I should have told this story. Yeah.
4/6, 5/6, 6/6, 7/6, 8/6, 9/6, 10/6, and 11. Oops. 11/6, because when you get back to there, you're at 12/6. What happens here, and I know you guys are like, and this is where you were talking, Sarah, about what happens, why we need to know where things wind up bouncing around, is how far is it from 0 to 30 degrees?
30 degrees.
30 degrees. How far is it from 180 to 150?
30 degrees.
Do they have the same reference angle off?
Yeah.
Which means they're going to have the same
So,
set of ordered pairs, but
That's
different. I'm not worried about but I'm not worried about that. But they're going to have the same ordered pairs, but they're going to be flipped as far as the signs SIG, and that's how we build lines, because it builds coordinates, and that's kind of what you're getting at.
Do you know if they have like also like on Google or something?
We do, and I'll give you one tomorrow. Yeah, I'll give you one tomorrow. I just wanted to start with this about how we can convert degrees to radians just by, well, all we did here to convert degrees and radians, guys, was we slapped a pi next to a number and divided by 180. So today we're going to work on not so much how this all works, but to convert a degree to radians. Well, if you're going to go from degree to radians like we did here, take any degree measure, 45, slap a pi next to it, and divide it by 180. Simplify. 45 is 1/4 of 180. So you got pi over 4. To convert from degrees to radians, any degree measure, take the degree value, multiply it by pi, and divide it by 180. Because if you did 360, you'd have to go 2 pi over 360. So they just simplify it out. Remember last year in geometry, there's a couple of things we did like 2 pi over 360. It was like arc length.
Yeah.
You could have just done pi over 180. it was redundant, that's all. But we kept it in terms of 360 because we wanted you guys to keep thinking of a circle, not in terms of radians. We're working with radians, you just didn't know it. Shh, don't. Your geometry teacher lied to you. Okay. So degree. Don't worry, we'll do it again tomorrow. I'm not worried. We're going to do this a bunch. Take the degree value, slap a pi next to it, divide it by 180. To go the other direction. To go from the other direction. What's that?
Oh, yeah.
Is that better?
I think when you try really hard, you still can't.
Take your radian value, multiply it by 180, and divide it by pi. Go.
And wait, what is the rate?
Sometimes you have to go back from radians to degrees.
What is the rate?
Radian values are always going to be simplified fractions with a pi next to them. For example, if I say that we have 20 pi over 7, and I want to know how many degrees that is, what I would do is I would multiply that by 180 over pi. Here, the pi's cancel out, and I get 3,600 divided by 7 degrees. I don't know what that is.
Can you have pi?
Well, that's why you divide it out. That way it goes away. You're getting rid of the pi and switching it to degrees. Yeah.
What is a radian?
Radian is just it's a unit of measure that deals with the circumference versus degree measure. You're looking at it in terms of a relation of a circumference.
So is it just arc length?
Kinda. Yeah. It is. It's arc length is the actual distance on it. The radian measure is the angle that creates that arc length. If you remember that, because of central angle over 360 times 2 pi r. Well, that's pi over 180. You're converting the angle measure to that.
Will we get like a calculator to just write it
No. No. You don't need a calculator for any of this. You'll be surprised. Because what happens is you'll get stuff like this.
1,600 over 7.
Yeah, it's just some crummy number. I just made something up off the top of my head. This is 13.
So you want us to leave it in fraction? I was gonna say, 'cause if you want it in a decimal, you just allow that.
No, I don't want it in decimal. I don't really care what it is. So, for example, if I wanted to convert 18 pi over 4 into degrees, if I want to turn that into degrees, I would take it and multiply it by 180 and divide it by pi. Well, just simplify your fractions. The pi's go away. 4 goes into 18. Well, this becomes a 2. That's a 9. 2 goes to 180, 90. 9 times 9 is 8, 81, 810.
I keep forgetting we don't have calculators.
That's all you're doing. You're simplifying and working with fractions. That's what you're saying.
Yay!
So you guys were working with radian value. You just didn't know you were working with radians.
It actually.
Okay. That's what you're doing. Okay? And yet the idea here at 810, well, you could actually draw that. 810 is how many times around? Well,
A lot.
360, 720. How many more degrees do you have left to go to get to 90? So you'd wind up here. Okay? Yes, sir.
Why am I using
Now, let me show you this. How do I draw that? How do I draw that in radians? Remember how I mentioned that mixed numbers are stupid? Yeah. There's very few occasions that mixed numbers make any sense at all. This is one of them. Okay? So what I want to do is I'm going to see 4 goes into 18 how many times? There's 4, and then how much are left? 2/4? I know you guys are saying 1/2. So we'll say 4 1/2 pi. Same idea. Do you guys agree? Now, if I'm going to count this in terms of radians, that means I'm counting it in terms of pi. Well, here's 0. 1 little, 2 little, 3 little pi's, 4 little, and now where's half pi?
Wait, what is it? 1 little? What is that?
I'm just counting.
Like, I'm not turning.
Wait,
No, no. You're okay with the convert, right? Okay. This is 0, this is pi, this is 2 pi. 1, 2, 3, 4. Where's half?
Okay, I get what you do. Now I was so confused in my way.
So, actually placing angles in radian measure is really easy because all you're doing is you're moving things around in terms of pi. You're counting mixed numbers. Okay. Now, if I wanted to find, guys, if I wanted to find positive and negative coterminal angles in terms of radians, instead of adding and subtracting 360, what are you going to add and subtract? Well, what's 360 in terms of radians is how much? 2 pi. So instead of adding and subtracting 360, I'm going to add and subtract 2 pi. But a lot of times what I'm going to do, instead of adding and subtract, that's the question. I'm not going to add and subtract 2 pi here. I'm going to keep it in terms of, since I know this is past it, I'm going to keep it in terms of the same fraction. I'm going to use fractions to make my life easier. Because you're going to add and subtract with common denominators. Generate the common denominators right away. It's quicker. That's what I'm saying. Instead of adding and subtracting 360, you're adding and subtract parts of 2 pi. Okay? Yeah. And I know this is a lot. There's a lot of stuff today. You're going, oh, you guys are drawing. Oh my God, I can't redraw that. Don't worry if your diagram looks like crap. It's okay. It's quite all right.
I gave up and drew it bigger.
And that's fine. I have really nice charts that we will build and we're going to work through. But I don't want to get that into it right away until we start worrying about actual ordered pairs. For right now, it's just a matter of, can you get the idea of why things are moving a certain amount of degrees or a certain amount of fractionals each time? As far as where things get placed and building out that entire circle, we can do that later. It's not a necessity for right now. Yeah.
So how would you solve
For what? Doing this? I would do the same thing. I'd get within 2 pi first. So I'd subtract, and I'm at 10 pi over 4, which means I'm still beyond 1 revolution. So I'd subtract it again. And that gives me 2 pi over 4. So there's my first coterminal, but then I would simplify it. And then I would subtract it again. And I would have negative 6 pi over 4. And there's my coterminal angles, common denominators. So my positive and negative would be at pi over 2 and negative 3 pi over 2. Just like I gave it degrees? Yep. The exact same rules, but with the radian.
Wait, so less than 2 pi or bigger than negative?
Plus or minus 2 pi.
Well, we actually use
Everything after this class. Everything gets measured out in radian. Because you don't, it's a, yeah. They're all going to be and that's the idea behind this is because you don't need to use a calculator. I forgot the actual problem numbers. I didn't write it down. Let me pull this up real quick. Haha, right.
Draws his in the bat like vertically.
Do those,
It's a mess.
please.